Today we're going to talk about a concept called expected value. Sometimes the chance of all outcomes is not the same. So what we like to do is talk about what would occur if the event were to happen over and over and over. Then we could see what is called the expected value. In order to find the expected value, each of the outcomes must be numerical, and the sum of all of the probabilities has to add up to 1. In order to find the expected value, what we're going to do is we're going to do the summation of the probability that an event will occur times the outcome. And the reason why I use the summation is because we will calculate this for each outcome that could occur. For example, finding the expected value of rolling a standard die. When we roll a die, there are 6 outcomes. We could have a 1, a 2, a 3, a 4, a 5, and a 6, and each has a probability of 1/6 chance of occurring. So we would say the expected value of rolling a die, and notice the notation here, we use an E to denote expected value in comparison to how we use a P to denote probability of. So the E means expected value, so the expected value of rolling a die would be 1/6 times the value of 1, 1/6 times the value of 2, and so on, and we will do this for all of the values of our die. And if you multiply all of these out, we will get 3.5. Now, example 1 differs from example 2 because in example 2 we have what is called a loaded die. The problem says find the expected value of rolling a loaded die where the probability of rolling a 1 is 0.5, the probability of rolling a 3 is 0.25, and the rest of the values have the same probability. So out of my 6 values, the 1 and the 3 have values that are listed. So therefore the 2, the 4, the 5, and the 6 all have to share the rest of the probability. And 0.5 and 0.25 is going to give us 0.75 or 3/4 of the chances. So these last 4 choices are going to share the remaining 1/4 probability, meaning that they each have a 1/16 chance of occurring when you do 1/4 divided by 4. So our expected value here Alright, our expected value here of rolling this loaded die would be found by doing a 0.5 times the value of 1 plus a 1/16 times the value of 2, a 0.25 times the value of 3, and then again a 1/16 times the 4, the 5, and the 6. And if we type this all in the calculator, we will get an expected value of 2.3125. So as you can see, the loaded die changes the probability of each number occurring. The next example that we have deals with gift cards. So I have 20 gift cards and I am selling them for $3 each. 2 of the gift cards have a value of $20, 5 of the gift cards have a value of $10, and the rest of them have no money on them. If you buy a gift card from me, what is your expected net monetary gain? Now, net gain means, this is going to be the amount you will have after the $3 investment. So if you were to purchase a ticket for $3 or purchase a card for $3 rather, and the card had a value of $5, then your net gain would be $2. So there are two ways that you can do this. One way that you can do it is you can say that the expected value for each card has decreased by $3 because you have to take away the amount that it costs to purchase the card. So I could say that the expected value of 20 is really $17, and there are two gift cards that have a value of 20, so we would say that that probability is 2 out of 20 for occurring. There are 5 gift cards that have a value of $10, so their probability of occurring is 5 out of 20. And if the card has a $10 value, its net value will be $7. And then the rest of them have no money on them at all, so their net value is actually going to be negative money because you paid $3 and you got nothing back. So we had 7 gift cards accounted for, meaning that there are 13 out of 20 gift cards that have a value of negative $3 on them. So if you went ahead and multiplied this out, then we would find out that our expected value is to get $1.50. Now, if you don't like doing it this way, the other way that you could do it is you could calculate the expected value using the amount on the gift cards, and then after you get your answer, this would result in $4.50, you subtract the $3 cost to purchase the gift card, and you would get the same answer of $1.50. So it doesn't really matter which method you use as long as you remember to account for the $3 cost of the ticket, or the gift card rather. Okay, go ahead and read the next problem and try and complete it on your own, and when you are done, unpause the video and see how you did. In this case, the percent of people that have been surveyed for the number of hours of homework done needs to add up to 100. So if I look at the numbers that I have and take 100 and subtract each of those values, we will find that the missing percentage is 16%. And then when I'm calculating the expected value, the expected number of hours of homework done each night will be each of these numbers written as a decimal, so 0.31 times 0 plus 0.16 times 1, and so on. You need to remember to write them as a decimal because probability always has to be between 0 and 1. And then we're going to go ahead and calculate this out. And we get that the expected number of hours of homework done each night is 1.62 hours. Okay, go ahead and read example 5, pause the video, and restart it when you're done. So here, when we're calculating our GPA, we will do the probability of each GPA, so 0.15 times the value of 4, plus 0.3 times the value of 3, 0.4 times the value of 2, 0.1 times the value of 1, and 0.05 times the value of 0. And we will get an expected value, or an expected GPA, of 2.4. And this makes sense because we know that we have 40% of our grades are a C, so the GPA there here makes sense. Alright, in our last problem we're taking a look at the Lotto. So, if Lotto tickets sell for $1 and you have a 1 in 20 chance of winning $10 and a 1 in 100,000 chance of winning $10,000, what is the net expected value? Again, pay attention to that number net. So there are two ways that you can go about doing this. One way is to subtract the dollar paid for the ticket right away, and then you don't have to adjust your answer in the end, and that's how I'm going to go ahead and do this. And our events that we could have occur is we could win $10, we could win $10,000, which would be ideal, or we could win nothing. So each of these events has a probability of occurring. The event of winning $10 has a 1 in 20 chance of happening. The event of winning $10,000 has a 1 in 100,000 chance of winning. And then to figure out the chance of winning nothing, we have to take 1 and subtract 1/20th and subtract 1/100,000th. And we end up getting that this has a probability of, you can either write the decimal 0.94999, or you could write it as a fraction 94999 over 100,000. Okay? So regardless of how you do it, either the decimal or the fraction, that would be the probability of that event occurring. Now we need to write the expected value for that event. So if I win $10, I'm really only winning $9 because I had to pay $1 for my ticket. If I win 10,000, I'm really only netting $9,999, although really who's counting if you win $10,000? And if I win nothing, I'm actually losing $1. So let's go ahead and calculate all of that out and figure out what our expected value is for our Lotto ticket. And if we calculate all of this out, we should get negative 0.40, which means that on average, you can expect to lose 40 cents per ticket purchased. And remember that that's actually considering the $1 that you paid for the ticket. So on average, buying Lotto tickets is definitely not going to pay off. All right, thank you very much, and we will talk about this tomorrow as we recap our lesson, work within our groups, and then prepare for our upcoming test.